It's funny. I was just thinking about how much we rely on automated systems to run perfectly all the time
Absolutely.
in the background. In the background, yeah. And I'm always surprised how often I forget some simple, recurring task myself. It got me wondering, how did early computers handle this? How did they manage scheduled repetition?
And that question takes us right back to the source.
It does.
Today we're doing a deep dive into cron, the quiet little shell command that basically defines scheduled automation. We're going to trace its journey from a pretty inefficient brute force tool
Right.
to this really elegant intellectual breakthrough that made modern multi-user systems possible.
So cron itself, at its heart, it's pretty simple, right? It's a command that schedules a recurring task, a so-called cron job.
That's it. And the name is just perfect.
It's from Chronos, the Greek for time.
Exactly. It couldn't be more direct. And the whole thing is driven by a configuration file, the cron tab.
Which is where you actually tell it what to do.
Right. It has 5 fields: minute, hour, day of the month, and day of the week. It's a classic example of stateless pattern matching, a simple fixed pattern that triggers an action.
But that first version, back in, version 7 Unix around 1975, it wasn't elegant at all.
Oh, not at all. It was brutally simple. And because of that, it was hugely inefficient.
How so?
Well, the whole algorithm was based on constant polling.
Yeah.
The service would wake up, read the entire list of jobs.
Every single time.
Every single time. It would check if any job matched the current time, run it as the super user, and then just sleep for exactly 1 minute.
And then wake up and do it all over again.
Yep. So it scaled with the passage of time, not with the amount of work it actually had to do.
Which must have just eaten up resources, especially back then.
It was a crisis. I mean, in the late 70s, Purdue University did an experiment. They tried to use this for the 100 users on their main time-shared computer.
A VX7 1780, right? That was a serious machine.
A very serious machine. But the constant polling just brought it to its knees. They realized pretty quickly the brute force approach just would not scale.
Okay, so that model failed completely under load. What was the big idea, the conceptual shift, that let System v Unix handle hundreds of users without this constant drain?
So the breakthrough came with System V, which was really aimed at making Unix a commercial, scalable OS. A researcher at Purdue, Robert Brown, he recognized something.
What was that?
He saw that cron's job queue was basically analogous to the systems used in discrete event simulators.
Ah, okay. So those systems don't care about a real-time clock. They just jump from one scheduled event to the next.
Precisely. So instead of asking, is it time yet, every 60 seconds.
It only has to ask, when is the next time I have to do something?
You've got it. They implemented something called the Frantomeli Event List Manager. So the new cron would calculate the exact future timestamp for the very next task.
Whether it's in 4 minutes or 4 days.
Right. And it would just tell the kernel, wake me up at that precise moment. It's like having a smart calendar reminder instead of checking your watch every single minute.
And that's the core difference, right? Is between constant work and deep, efficient rest. Resources are only used when work is actually needed.
And that allowed cron to scale with the work assigned, not just with time passing.
That's the idea that made modern multi-user systems and really the whole automated server world feasible.
It really is.
And that same dedication to algorithmic efficiency, to saving resources, it's still driving innovation today, whether we're optimizing old servers
or integrating cutting-edge AI.
Exactly. And speaking of that kind of efficiency, this is actually a perfect moment to mention our sponsor. For anyone interested in automation, AI training, or software development, especially figuring out where AI agents can make the most impact for you, you should check out embersilk.com for all your AI needs.
So moving into the modern era, things have mostly been about security and standardization.
Like Vixie Cron from 1987.
Yeah, that became the dominant version. It added crucial security features, better logging, things you absolutely need for big multi-user systems. But the core logic, that breakthrough idea, it remained unchanged.
And that spirit of building shared, reliable tools is still going. Just in 2025, the OpenCron Patterns Specification was published.
And that standardization is huge. It formally standardized that 5-field format, which finally resolved all the little differences between implementations. It ensures this decades-old tool continues to be a reliable foundation for infrastructure all over the world.
So when you boil it all down, what's the big takeaway here?
I think it's that the most essential automation tool we have isn't about massive hardware or brute force.
No, it's this elegant, decades-old algorithmic solution. It's just a brilliant idea about how to efficiently manage future events.
It's proof that simple algorithms designed to conserve resources can, really drive human progress forward.
It makes you think about the power of just simple pattern matching.
It's fascinating, right? How many incredibly complex modern technologies still rely on Crickran's core ability to just reliably match a time signature against a simple fixed pattern.
Yeah.
That's what ensures our digital world wakes up precisely when it needs to.
If you enjoyed this deep dive into time, efficiency, and elegant solutions, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.